Okay, so let's put some of the factoring and quadratic formula and maybe completing the square stuff that we've been learning recently to work here. Okay, so one of the applications that quadratics fits to fairly nicely is vertical motion. And basically, we want to be able to calculate the time, or relate the time, to the height that something's in the air. Okay, so if we have a time, we want to be able to find a height. If we have a height, we want to be able to find how long it's been in the air for. So, quadratics makes a nice model for that. So let's go and do an example here. Okay, so it says the ball is kicked upwards, and it can be modeled by the equation h is equal to 35t minus 5t squared, where h is the height of the ball in meters, and t is the time in seconds. So if we draw a little picture here, we know that our time t is along the x-axis, and it is in seconds. Okay, and our height along the y-axis is in meters. And they've given us this nice nifty little formula that we can use here that says that it models the path of our ball perfectly. Okay, so it says how high is the ball after 3 seconds? Well, they're always going to have to give us one of the two pieces of information. They're either going to have to give us time or they're going to have to give us height. And we're going to use that information to find the other variable, because here's the path of my ball, right? So at any given time, there's only going to be one height, okay, because it's a function. Okay, so it says here if the how high is the ball after 3 seconds? So we know that 3 is a t. T is equal to 3, so we can just plug that into our equation. H is equal to 35 times 3 minus 5 times 3 squared. Okay, so dump that into your calculator or do whatever you need to do to find out that 35 times 3 minus 5 times 3 squared gives me 60. So my height at 3 seconds is going to equal 60 meters. Okay, so that's kind of the easier one. We just input t into the equation and get a value out. Okay, but here in B, it's given us something a little trickier. It says after how many seconds will the ball be 50 meters high? So we're looking, so this first one, 60 meters at 3 seconds here. Say this is 3. We're going to have a height of 60 meters, right? Okay, but now we're looking at when is the ball going to be 50 meters high. And it looks like we're going to have, we could have two answers that way. It looks like on its way up it's going to get a value, and on its way down it's also going to hit 50 meters. So this is a height, so that means I've got to substitute that into my h. So I'm going to say 50 is equal to 35t minus 5t squared. Okay, so I put my 50 where it's a height because they gave me a height. Okay, and now I'm going to go solve for this, and now it's like, okay, I've got a t squared and a t here, so I've got to use one of my methods for solving a quadratic equation here. And this one looks like, I'm going to try factoring with this first. So let's set our equation to 0 like we always do. Okay, so I'm going to bring these two over to the other side. So I'm going to subtract 35t from both sides and add 5t squared to both sides to put this in a standard form over here. Zero. And I'm going to try factoring it out. So it looks like I can make life a little easier on myself if I divide everything by 5 here. So divide everything by 5, and that's going to give me my original equation. Now looks like this: t squared minus 7t plus 10. That's all equal to 0. And now I can get my solutions from factoring just this inside part here, right? So 5 times my two factors, what I'm looking for. And I'm trying to look for numbers that multiply to 10 and add to -7. So I think if I used, well, let's put our t up here first and here. And now if here, let's do this the long way here so people can see what's going on. So I want numbers that multiply to 10t squared and numbers that add to -7t. So what two numbers multiply to 10? Well, 2 and 5 do. And can I get 7 from 2 and 5? Well, I can if I make them both negative, which turns out nice. Okay, so I know that I'm going to get t minus 2 and t minus 5 there. And so my solutions, okay, what makes this equation 0 now? It's easy to see, right? If I put 2 in here for t, that's going to make my equation 0. So at 2 seconds, looks like my ball could be at 50 meters high, and also at 5 seconds. Okay, and so those are both good times. They're both positive. So looks like that'll work. Okay, so 2 and 5. That's when the ball is gonna be at 50 meters high. Now, when will the ball hit the ground? Well, they didn't really give us a number here, but what height is the ball going to be at when it hits the ground? Well, it's going to be at a height of 0. So what they're really asking is when is h equal to 0? Okay, so again, I'm going to go back up into my equation, and I'm going to substitute 0 now in for where my height is. 35t minus 5t squared. And I'm going to do the same thing. Okay, I'm going to factor that out and see what my solutions are. So let's go ahead and do that. Looks like I can take 5 out again. 5t out I can take. Okay, and that's going to leave me with 7 minus t. So it looks like the ball was on the ground 2 times here. It's going to be on the ground when he kicks it, and it's also going to be on the ground when it lands after he kicks it. So am I going to get 2 times here? Sure enough. Okay. In this one, what makes that factor 0? 0 does. 5 times 0 is equal to 0, so 0 times whatever this is going to be 0. And looks like I can also use 7. 7 is going to come out of this factor. So my 2 times where the ball is on the ground, okay, so is when it starts. And I guess this question specifically is saying when will the ball hit the ground, so that's after he kicks it. That's our answer. It's going to hit the ground after 7 seconds. Okay. Let's give another question a try here. Okay, so it says an archer shoots an arrow into the air, and the equation that describes the path of the arrow is h is equal to 17t minus 5t squared, where h is the height in meters and t is the time in seconds. So again, they can only ask us for a piece of information if they give us the other. We've got h's and t's, so times and heights for our variables. So if they give us one, we can go and find the other. Okay, so here they give us a time, 2 seconds. T is equal to 2. So I'm going to go input that in there, and it's going to tell me how high the arrow is. So the height of the arrow is equal to 17 times 2 minus 5 times 2 squared. Okay, so that gives us, looks like, 34 minus 5 times 2 squared. That looks like 20. And so after 2 seconds, after the arrow has been in the air for 2 seconds, it looks like our arrow is going to be 14 meters high. Okay. Okay, so let's go to our next question here. So when will the arrow be 10 meters high? So here our h is equal to 10. So I'm going to put it back into the equation as 10 is equal to 17t minus 5t squared. And now I'm left to solve the quadratic equation. So let's put it into standard form here. okay, by adding 5t squared and subtracting 17t from both sides. Okay, and I'm going to solve this one by using the quadratic formula. Okay, so sometimes it's nice to just find the discriminant, the part under the root sign for the quadratic formula first. So I'm going to do that first. So b squared is minus 17 minus 4 times a is 5 times c is 10. So here, let's write this out at the side. A is equal to 5, B is equal to minus 17, and C is equal to 10, right? So I'm just putting that into the discriminant. And if you dump that into your calculator, you're going to get 17 squared minus 4 times 5 times 10 is equal to 89. So D is equal to 89. Okay, so let's go and dump that into our quadratic formula now. So x is equal to negative b, so negative minus 17 plus or minus, now we got the discriminant already, square root of 89. And because we know this is not a perfect square, we couldn't have factored it, right? So it's a good thing we chose the quadratic formula. So, and we're going to all divide that by 2a, which is 10. So in your calculator, you're going to want to input these like this. Okay, so x is going to equal 17 plus the square root of 89, and you're going to want to put that in parentheses so your calculator knows to do the addition before you divide it by 10. Okay, so we're going to get one answer from our plus sign here, and we're going to get one answer from our negative sign. So our other x is going to be 17 minus square root of 89 all over 10. Okay, and that's got to be in parentheses on top. So let's see what x equals. Okay, so 17 plus the square root of 89 all divided by 10 equals, looks like 2.6. So after 2.6 seconds, our ball or our arrow is going to be 10 meters high, and then 17 minus square root of 89 all divided by 10. That's going to give us 0.75 or 0.7 seconds. Actually, it's 0.8 seconds. X is equal to 0.8 seconds. So those are the two times. On the way up, it's going to hit, after 0.8 seconds, it's going to be 10 meters high, and after 2.6 seconds, on the way down, it's also going to be 10 meters high. Okay, so when's it going to be 20 meters high? Well, this one, it looks like let's do the discriminant first here. Okay, so our equation here, 20 is equal to, what was our equation here? 20 is equal to 17t minus 5t squared. Okay, so my h was 20, so I just plug it into the height part. We'll put it into standard form like we did the first time. Is equal to 0. Now let's take a look at the discriminant here. Okay, so b squared minus 4ac is going to give me minus 17 squared minus 4 times 5 times 20 this time. Okay, and when we put that out, 17 squared minus 4 times 5 times 20, that equals negative 111. So my discriminant is equal to negative 111. Oops, 111. So because it's a negative number, I know there's no solutions to this equation, which means that my arrow never gets up to that 20 meter height. Okay, so because my discriminant is less than 0, there are no solutions, no real solutions. So our arrow, the arrow never reaches 20 meters.